Hello guys, welcome to today's class. In today's class, we'll be discussing this very interesting question. Find the y, the x at the indicated point. And the problem is 1 over 2x sine pi y plus y minus x squared equal to 0 at the point minus 1 over 2 comma 1 over 2. Now, at the end of this video, and you are able to follow up through and you find this video very interesting and educating, please do well to subscribe to the channel. Now, how do we solve this problem? We know that this is definitely an implicit function because on the left hand side we have a mix of x and y. It is not explicitly giving us y equal to some function of x on the right hand side. Instead, we have a function of x and y on the left hand side equal to some constant on the right hand side, and that is an implicit function. In my previous video, I explained how to differentiate a function implicitly, that whenever you see the dependent variable, whenever you're differentiating the dependent variable, which is y in this case, you return dy dx. That is the simple rule. Or every other rule follows. If there's a product rule, you should apply a product rule. Any rule follows. If there is quotient rule, you apply quotient rule. But whenever you're differentiating y, you return dy dx. And that's as simple as that. Now, to differentiate this function, we can directly differentiate, but I want to eradicate this fraction here. We can actually work with the fraction, but let me get rid of this fraction by multiplying through by 2, right? So let's look at this. If I multiply through by 2, this is definitely x sine pi y plus 2y, because this multiplies this, minus 2x squared equal to 0. 2 is multiplying everything. When 2 multiplies 0, is still 0. Okay. Now, the next thing is to tackle this differentiation with the rules we've learned so far. In my previous videos, I've explained how to differentiate using product rule. When you see a function multiply this way, it's a product rule. But you should also pay attention to this sign of pi y. This is a chain function, and I've made a video on chain rule. So you can go back to my previous video on chain rule, you see how to differentiate this. But I'll still try as much as possible to make it as simple as it can be. Now, let's differentiate this function using our product rule. What does product rule say? Is that if you have a function multiplied y equal to uv, where both of them are functions of x, you hold the first term, differentiate the second one, you hold u, differentiate v with respect to x, then hold v, differentiate u with respect to x. So we'll hold this first term x, and then differentiate this term. But because this term is a chain function, we first of all go inside. We go from the innermost function and then differentiate outward. So we differentiate pi y, because pi is a constant. So the differential of a constant multiplying a variable is just the constant. So when I differentiate this, pi y, I will have pi. Just like differentiating 2y, you have 2. Differentiating pi y, you have pi. But remember, we are differentiating y here because there's y here. So we return dy dx. So we return dy dx. Remember, whenever you're differentiating a chain function, we differentiate the inner function and you get a value, you now need to go outward. So we now differentiate sine of anything is cosine of that value. And we are done with that first part of the product rule. So we hold this, differentiate the whole of this. Next, we hold this one now, differentiate x. So we hold sine pi y, then differentiate x, we have 1. Whenever I differentiate x, you have 1. So we move plus differentiate 2y, you have 2. But because we are differentiating y, you don't forget, you return dy dx. So we return dy dx. We move differentiating 2x squared, we have 4x, right? And then differentiating 0, we still have 0. We are done with the derivatives here. The next thing is to simplify and collect like terms, make the y dx to the formula. And after that, we proceed to impute these values at the indicated point. So this gives us, so this is okay, we have pi x cos pi y. I would prefer to keep dy dx at the end. So this is dy dx. Plus, when I multiply this, I have sine pi y, because this times this is still the same thing, plus 2 dy dx, then minus 4x equal to 0. The next thing is to collect your like terms. So all the values with the y dx should be on the left hand side. So we have pi x cos pi y dy dx plus 2 dy dx. All the terms with dy dx should come to this side. Then we move this one over. But because I'm seeing negative here, I would prefer to move this one first so that it will be positive on the other end. I have 4x. When I move this, I have negative sine pi y. Okay, then the next thing is to factor out my dy dx. If I factor out dy dx, if I factor dy dx from this, I have pi x cos pi y. Okay, so factor out dy dx from here, I have plus 2. And I'm done with that. This is equal to 4x minus sine pi y. Now the next thing is to just make our dy dx subject to the formula, and we move to the next step. So from this, we can now make dy dx subject that dy dx is equal to the whole of this 4x minus sine pi y all over this. So this is pi x cos, okay, this is pi y here, cos pi y plus 2. Okay, this is our dy dx. Now the next step is to use this point. We said find dy dx at the indicated point, this. So at the indicated point, we can write that dy dx at the point minus 1 over 2, comma 1 over 2. We can define it this way. Some persons can say that you write, some persons can use the form dy dx at x equal to negative 1 over 2, y equal to 1 over 2. Please note that this is the value for x, this is value for y, x comma y. So you can write it this way, you can also write it this way. But let me use this. So this means that anywhere I see x, I have this first term. This is in the form x comma y, x comma y. Yeah. So whenever I see x, I will write negative 1 over 2. So this is 4 bracket negative 1 upon 2 minus sine pi. Y is 1 over 2. So I have times 1 over 2 all over, this is pi bracket x is negative 1 upon 2 cos pi here times y is 1 upon 2 plus 2. If we continue with this, we will have now 4 times half. 4 times half. This 4 times negative 1 is negative 4 divided by 2. So we have a negative 2 here on the top here. Then minus, this is pi over 2. This is sine pi over 2. Because pi times 1 is pi divided by 2. All over. This is pi over 2, negative pi over 2. Because pi times negative 1 is negative pi upon 2. Then we have cos. This is pi upon 2 plus 2. Now, it is important to note that for trig function, sine is a trig function. Sine x, cos x, they are trig function. In trigonometry, pi is given as 180 degrees, right? So this is pi given as 180 degrees. So if we continue with that, this is like pi over 2. So this will be negative 2 minus sine 180 degrees over 2 all over negative 180 degrees over 2 cos 180 degrees over 2 plus 2, right? If we continue with this, you have negative 2 minus sine 180 divided by 2 gives us 90 degrees, right? All over negative 180 divided by 2 is 90 degrees. Cos 180 divided by 2, 90 degrees, right? Plus 2. And if we continue with this is minus 2 minus sine 90 degrees is 1 here. All over, this is minus 90 degrees. Cos 90 degrees is 0, then plus 2. And this gives us negative 3 all over. This is 90 times 0 is 0, so we have 2. and this gives us the value. So at the point minus 1 over 2, 1 over 2, we divide the x is minus 3 over 2. And that's the solution to that problem. Now, if you follow through this example and you follow through the various steps I've taken and you find it interesting and you want to follow more in other videos I will make, do wait to subscribe to this channel so that when I make more videos, you get notifications to follow through my videos.